So today we are working with a string problem. This is a LeetCode problem, number 125, valid palindrome. So let's read first. Given a string, determine if it is a palindrome considering only the alphanumeric characters and ignoring cases. So what is a palindrome first? So palindrome means reading it from the front and reading it from the back are equal. In other words, let's think of 2 pointers here. This is a left pointer, this is the right pointer. The value in the left pointer is A, the value on the right pointer is A. So these are matching. So once we know these are matching, we are going to move the left pointer once and right pointer once and check these values. M is equal to M. So we will keep going with it until these pointers meet. So we can think of it as a mirror effect, right? If we were to get a mirror image of the left side to the right side, if they are equal, then we call them a palindrome. What is alphanumeric characters? This is a fancy way of saying these are just letters between A, B, C, D to the Z. So which means ignore the semicolon, ignore the comma, and so on. So for the purpose of this problem, we define empty string as valid palindrome. Okay. The first example is true, and let's look at the false example here. R is equal to R, A is equal to A, C is equal to C, and we are left with what? We are left with A, E, and A. So they are not equal, which means this is not a valid palindrome. So once we understand the goal, let's go ahead and start coding this two-pointer approach. So for this two-pointer, like we said, we are going to define L, which L is equal to 0. And let's make sure we have the proper indentation. R is equal to length S. And because of zero indexing property of Python, we are going to deduct number 1 to reach the last value of the string. And then let's go ahead and start the loop. So this is the stopping criteria. While left index is smaller than right index, let's check if this is not an alphanumeric character, which means we are going to use a built-in function s.l. So which means the value of s in the lth index is alphanumeric, is alnum. So since we put the not condition in the beginning of the if statement, this is only gonna enter here if this is not an alphanumeric character. In this case, what we are gonna do, we are gonna skip this left index, which means we are gonna increase the index of left by 1. Else if, we are gonna do the same thing in the R index and check if this is a alphanumeric character or not. And we are gonna go ahead and reduce R by 1 if this is not an alphanumeric character. So we skip it. Else, which means SL and SR are both alphanumeric now. We are gonna go ahead and check if they are not equal. So in order to ignore the cases, I'm gonna go ahead and lower all these cases so we don't have to deal with capital and lower. So SR dot lower. Okay. So we are gonna, remember, we are gonna put a negative condition here. So I'm gonna add if not, which means if this is not correct, then what we are gonna do is we are gonna go ahead and return false, right? If we checked it and if it is same, then we are going to go ahead and increase the left index by 1 and decrease the right index by 1, which means we are looping. We are continuing checking the other indexes until L and R meets, right? So when we are done with this loop, which means we did not return false, which means it is still a valid palindrome up until this point, right? So what we are going to do is we are going to return true. In other words, this is a valid palindrome. Let's go ahead and run this. Okay, accepted. Let's go ahead and submit. Okay, this is a working solution. So now this is a working solution. I want to discuss the time and space complexity of what we did here. So we are visiting each and every element of the string, right? So this is an O-sub-n time. And what we are using here is we are using 2 pointers. So that gives this an advantage of space. So this is one solution that we can have, and we will of course comment this out. And then let's zero this out, make this default, and let's work on another type of solution that we can think of. So we can think of a list comprehension here. So we can prepare a new string here. So we can say I is equal to, we can say I for I in s.lower. Remember, we are dealing with the lower cases. If we are checking that if this is an alphanumeric character or not. So if I is alphanumeric, then go ahead and lower the case and then save it in this array. So what we are going to do now, we only have the alphanumeric characters. We are going to return if this alphanumeric character string is the same if we were to reverse it all the way. So let's go ahead and run this solution and see if this works. Perfect. So we are going to go ahead and submit, and then we will discuss the time and space complexity. So what is the time complexity? We are visiting each and every element of S once, so also then time complexity, right? And then we are working with an array here. We are recreating a string, correct? So we are using more memory in this solution, which is also n memory. So this is how we solve an example LeetCode problem.